All right, class, new unit, Unit 7, first section, 8.1, find angle measures and polygons. Now this unit is mostly over quadrilaterals, four-sided figures, but we do need to understand some basic things about polygons. So that's what this section is going to be focusing on, just polygons in general. First key concept here, we have the sum of the measures of the interior angles of a convex n-gon or any sided polygon. N is just there for showing it could be any number of sides. And remember, convex means all vertices point out, like this picture of this hexagon we have down here. All of the vertices point out. That's convex. And that is that an n-gon is n minus 2 times 180 degrees, all of their interior angles. And then the sum of the measures of the exterior angles of a convex polygon, with one angle at each vertex, is 360 degrees. All right, now this next definition, a diagonal of a polygon, we're not going to look at that today, but it will come into play in some later sections. But a diagonal of a polygon is a segment that joins two non-consecutive vertices. So if I were to look at my hexagon down here, two non-consecutive vertices would be like 2 and 6, 1 and 5, 6 and 3, 6 and 4, 3 and 5. You can see there's a whole bunch of them. 3 and 1. And I may have even missed some. Oh yeah, we have 4 and 2, 4 and 1. All of those are diagonals connecting non-consecutive vertices. All right, so into this first theorem here. Theorem 8.1, polygon interior angles theorem. So we're looking at our interior angles. The sum of the measures of the interior angles of a convex n-gon, in this case 6, n equals 6, 6 sides, 6 vertices, is n minus 2 times 180. So we can see we can plug in any number for n. However many sides our polygon has, we plug that number in for n. And then we use this formula, and it tells us what the measures of all of the interior angles added up will be. Now remember, triangles, all angles have to add up to 180, right? Triangles are a three-sided figure. So if we were to plug 3 in for n, we'd have 3 minus 2, which gives us 1. 1 times 180 is 180. And that's what all of the angles add up to, 180. If you know a four-sided figure like a square or a rectangle, all of those angles have to add up to 360. Plug in 4 for n. 4 minus 2 would be 2. 2 times 180 is 360. So that works with any polygon for the interior angles. So angle 1 plus angle 2 plus angle 3, and however many angles there are, plugged in for all added up, will equal n minus 2 times 180. So let's look at an example with this. We want to find the sum of the angle measures in this polygon. So we need to look at our interior angles. We have this convex hexagon. Remember, hexagon means 6-sided figure. If you didn't know that, you could still count all of the sides or all of the vertices. So I've got 1, 2, 3, 4, 5, 6 sides. So it's a 6-sided figure. Or I could count the vertices. 1, 2, 3, 4, 5, 6. 6 vertices. So it's a 6-sided figure. That's going to be my n value. So n equals 6. Hexagon told me that n equals 6. So if my formula is n minus 2 times 180, then I know I'll have 6 minus 2 times 180. Now it's important that if you're just punching things into your calculator that you use these parentheses. Your calculator will always follow the proper order of operations. Remember PEMDAS? It will always follow that. Parentheses, exponents, multiplication, division, addition, subtraction. That's what your calculator is doing. So if you don't have these parentheses around this subtraction problem, it's going to automatically just do 2 times 180 and then subtract that from 6 and give you some negative number. So you don't want to do that. You've got to do the 6 minus 2 first and then multiply that by 180. So it'll be 4 times 180, which gives us 720 degrees. So all angles inside of my convex hexagon up here will add up to 720 degrees. All right, next, we want to find the number of sides of a polygon. So in this case, we know what the sum of the interior angles is. It says the sum of the measures of our interior angles of a convex polygon is 2,700 degrees. So all of our angles added up equal 2,700 degrees. I want to be able to classify this polygon by the number of sides. So again, I'm going to look at my formula. In this case, I know that n minus 2 times 180 equals 2,700 degrees. So from there, I've got to be able to solve for n. So to solve for n, so again, these parentheses are important because those parentheses together mean that n minus 2 stays together as its own value. And then I have times 180. So if I want to get n, I first have to get n minus 2 by itself, and then I can work to get n by itself. So to get n minus 2 by itself, I can divide both sides by 180. Since I had multiplied by 180, I can divide by 180 on both sides. That cancels my 180s on the left. I'm left with n minus 2 equals, and then 2,700 divided by 180 gives me 15. All right, now I can drop my parentheses. I've got n minus 2 equals 15. And now I can add 2 to the other side to get n by itself. So the value of n is 17. So it is a 17-gon. 17-sided figure. 17-gon. Remember, if you don't, if it's one of these big values, it's not a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon, I think it was 12. If it's not one of those known named figures, just call it however many sides it is, gon. So it's a 17-gon. Example number 3, we want to find an unknown interior angle measure. So we're going to use this diagram here on the right to find angle K and angle L. So notice angle K and angle L are both congruent. They've got the congruent marks. So we know that they're going to be the same as one another. And we know our sum of all of our angles. Well, we see we have a 5-sided figure. We've got 1, 2, 3, 4, 5 angles, 5 vertices. So if I plug that in my n minus 2 times 180 formula, that becomes 5 minus 2 . 5 minus 2 times 180. So we've got 3 times 180, which gives us 540 degrees. So I know all of my angles will add up to 540, including K and L. So if I subtract the ones that I do know, what's left over will be K and L added together. So I can subtract 105 degrees, 109 degrees, and 68 degrees. And once I subtract all of that from 540, I'm left with 258 degrees. Now that is K and L added together. And since K and L are both the same, I can just divide 258 by 2. That tells me that each of them will equal 129 degrees. So the measure of angle K is 129 degrees. The measure of angle L equals 129 degrees. All right, next we're going to look at the exterior angles theorem. And this is that the sum of the measures of the exterior angles of a convex polygon, with just one angle at each vertex, is 360. So all of my exterior angles here will add up to 360. And you can see how we're forming these exterior angles. We're extending one side out a little further to be able to make an angle on the outside. Now, whichever direction we go, we've got to do that on all of them, and just one exterior angle at each vertice. Because I could extend it this other way too, if I didn't specify that I can only have one. So you can only have one exterior angle at each vertice. We want those to kind of be going the same way. Think of like, I don't know, if they're just all kind of almost going like a circle. So 1, 2, 3, 4, and 5 are kind of all in the same position for their exterior angles. And we know that all of them added up will give us 360, no matter how many exterior angles there are, they will add up to 360. So the more exterior angles there are, so the more sided figure it is, the smaller each angle measure will be. So for example number 4, finding the unknown exterior angle measures. So we need to find the value of x, and then we could use x to find our missing angles or our unknown angles. So we know they all need to add up to 360, so I can say x plus 89 plus 2x plus 85 equals 360. And then I want to solve for x, so I can combine my like terms. X plus 2x gives me 3x. 89 plus 85 gives me 174. And that needs to equal 360. I can subtract 174 to the other side. So 3x equals 186. And then divide by 3 on both sides to get x by itself. And x equals 62. So then if x equals 62, I know that angle up there is 62, and then 2 times 62 This angle would have to be 124. I was able to find my unknown angle measures. All right, last example. We're going to find angle measures in a regular polygon. Remember, a regular polygon means all angles and all sides are congruent. All angles are congruent, all sides are congruent. So this is talking about a lamp base. The lamp base of a lamp is in the shape of a regular 15-gon. So 15-sided figure. We need to find A, the measure of each interior angle, and B, the measure of each exterior angle. So let's first look at A. We know we're doing interior angles. So our formula for that was n minus 2 times 180. And we have a 15-sided figure. So n is 15. Minus 2 is 13. So 13 times 180 gives us 2,340. So that's all of our interior angles added up. We want to know the measure of each angle. So all of our angles added up give us 2,340. We need to divide that by how many angles we have. We have 15 angles. So 2,340 divided by 15 gives us 156 degrees. So each angle is 156 degrees. And then lastly, we want to figure out our exterior angles. All of our exterior angles are going to be the same because it's a regular polygon. And our formula for our exterior angles was all of the angles have to add up to 360. So I can take 360 divided by the number of sides, or the number of angles, which is 15. 360 divided by 15 gives me 24 degrees. Each exterior angle is 24 degrees. All right, that is it on 8.1. Make sure you do your homework.